labor, W is applied if a force is applied to an object, and this results in the object moving into the direction of the force. Therefore, labor is a scalar, not a vector, due to it only having force and no direction. Labor is the resulting force times distance. Therefore, labor equals ma times s. If you pull a mass at a certain angle of 12 Newton, you have to work out the horizontal force Fx by using s cos 40. We derive that from our cos rule, which says that it is Fx on s. We can then apply our normal power formula, W equals ma times s, which would give you W equals s cos 40 times 7, which would give you 64,348 joule. Power is measured in watt. The definition is it's the tempo at which labor is applied. So the formula is labor applied divided by time. P therefore equals W on T. Energy, on the other hand, is the ability to perform labor. Power is therefore the change in energy. Different types of energy is kinetic energy and potential energy. Kinetic energy, movement energy, takes an object from standing still, that's beginning velocity of 0, at a resulting force of Fr and distance s at a certain velocity, and then W equals Fr times s if there's no friction. Therefore W is MAS. Also remember your general formula, V square equals U square plus 2AS, and that would give you W equals M square times V square minus U square on 2, which gives you kinetic energy equal to a half mv square. For potential energy, if you have a certain mass going up a certain height, then you get energy applied, which equals mg. Your potential energy therefore equals W, which is mgs, and your potential energy formula from that applies generally as mgh, and h is your height. The law on the conservation of mechanical energy says that total energy in a closed system is constant. Therefore, mechanical energy equals that the sum of potential and kinetic energy must equal 0. If you have a pendulum swinging at any point, the kinetic energy from A to B equals the potential energy from A to B. Therefore, the mechanical energy is the same everywhere. Your potential and kinetic energy on top is the same as your potential and kinetic energy at the bottom. That's if you drop an object. If we work out kinetic energy for a falling object, we would have our mass at the top, middle and bottom. We would have a total height h, a distance to where it fell already, which is x, and then from the bottom h minus x. Above, the mechanical energy equals potential and kinetic energy added up, which equals mgh. In the middle, your mechanical energy equals mg times h minus x, which equals mgh minus mgx. And your kinetic energy equals a half mv squared, which equals a half m times 2gx, equaling mgx. Also remember your general formula of v square, then you'll find that v square equals 2gx. So in total, the mechanical energy equals potential and kinetic energy added up, which will give you at the end mgh. At the bottom, your mechanical energy equals mgh, potential energy is 0 because it already fell, and your kinetic energy works out to mgh as well. So this is where you work out this law just explained.